Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 315 count subarrays with fixed bounds. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. So this one, I probably should have gotten it earlier, but I was just too arrogant. And what I mean by that, I'll explain in a second. But yeah, so basically, there's a number of observations, and we'll go over them one by one. The first one is that obviously I actually did it in a couple of different ways, but I spent a long time on a wrong solution because initially I just thought that you needed to get the length of the components, right? So meaning that if this is 4, then it's just 4 times 3 over 2 or something like that. But then of course that's not true because you need 1 and a 5, so you cannot like just do an n choose 2 type thing. Where here you can, but yeah. So then the idea next is that, so I spent a lot of time there. You could watch me solve it during the contest. I don't know, was funky about it. The second part is that obviously, or maybe not obviously, but one thing that you can do actually, understanding the problem a little bit more, is that you can split them up, or you could only consider the subarrays in which like you can, because let's say you have a number that's outside of the range, right? That means that no matter what, there'll be no subarrays that goes by it. So then now you're dividing the subarray or the array into different subarrays where you're partitioning by numbers that are outside the range, right? So that means that for here, so one way to say this is that, let's say you have this problem, you can also convert this to 2 problems, which is that you get rid of the 7, and then you have to, something like this, and maybe if you have something like 1 3 5 2 5 2 5 1 or something like this, well actually, like maybe I have a 7, then this also factors, something like that, right? That's the idea, is that now instead of one problem, you have many different problems that are independent of each other, because no matter what you do in one component, you cannot touch the other component, right? So that's the observation. And I kind of did it here with this one-liner. Don't worry, we'll go over it. But I grouped it by whether it is a number is within the range, and then if this is within the range, I just do a solve on that sublist. And this is the tricky part for me that I took pretty much the rest of the contest on. And as soon as I kind of noticed what to do, it was pretty straightforward, to be honest. And this is where I said I was arrogant. Why was I arrogant? Because I kind of was trying too hard to visualize it in my head. I didn't look at the tapes yet to kind of see the exact timing, but I spent a long time doing that. So what do I mean by that? The problem that I couldn't figure out was how to do it without overlaps. What I mean by that is that, for example, if I do something like 1 3 5 2 here, and the max and min is 1 and 5, then I can do here, right? And then the 5, maybe something like this. Actually, let's just convert this to 1, right? So I could, so this is a possible sequence. But if I do it the other way, meaning that if I count, let's just say I have 1 3 5 is required. I don't know how I got 2 here. Then you start kind of growing these, and this is a possible subarray, so forth. And then let's say you do it the other way, 5 2 1, and then you expand it the other way, right? You have 3 5 2 1, and then 1 3 5 2 1. So of course, in this case, this number and this number appears, these two subarray duplicate, right? So that means that you have to try to count things in a way such that you're able to do them without duplicating it. Because if you do, then, well, you're just going to overcount, and you have to figure out how to subtract them out. That's what I spent a lot of time subtracting them out in my head. Yeah, because basically the idea, or the function that, or the idea that I had was that, like, okay, let's say I'm looking at this sequence, right, or this subarray. Like, let's say we're here caring about this subarray, right? How many valid subarrays are there to solve this, right? Well, it's actually not that bad to do it. If we don't worry about double counting, then that means that on the left side you have 2 numbers, right? 2 numbers on the left side of 5, so you have 2 numbers. In this number you have 3 numbers on the right side of the 1, so you have 3 numbers, right? And that means that there's 4 degrees of freedom here and 3 degrees of freedom here. That means that there's actually 12 possible ways that contains these 5 and 1 in the solution. Hopefully this part makes sense. It's because basically here you have 4 degrees of freedom, meaning that you could have 0 extension, you have 1 extension that includes the 2, you have 2 extension that includes the 2 and the 5, and all the way to the right, and also the same with the left, right? So that was the core idea that I was trying to build off, and I was like, okay, but if this is the case, how do I extend, how do I work on the, there's overlaps here. So then how do I figure out like how to overlap or remove the overlap, right? So what happened, what I did during the contest, and I always tell people to do, and maybe I would have done it if I was at home. I'm in San Francisco this week, because I have pencil and paper, and here I was relying on my brain too much, but I'm a little bit old, and that's what I mean by arrogant, and I couldn't figure it out. And if you watch me, during the contest, during the virtual contest, you'll see that I actually at some point wrote things out like I did here. And then I was like, okay, what if we just look at to the right, right? Meaning that to avoid, my thought process was, okay, to avoid overlaps, well, we just have to look to the right. So instead of here extending to the left, we just don't. That's the short answer. Instead we have this, and then we kind of just only look at to the right, right? And then only to the right, and you could extend this anyway. But so in this case, there are no overlaps because we know that no matter what, if we're only consistently looking only to the right, then it doesn't. Then there'll be no overlaps because there's only one case. Another way of saying it is that it would start at this number and then, see how far right you can get, right? And because every number that's before this will contain, additional numbers to the left, then you know that this is a unique subarray. So that's basically the idea. And then from there, my next thing was, okay, but not every subarray begins at a 1 or a 5 or the min or the max. So then here I extended to be, oh wait, I can do it at 5 as well. So then here I look at the 5, like the 3 is not a 1 or a 5, but you know that it has a possible thing. So then now look at how it extends. And then finally, after I kind of visualized this out, and this part I actually did in my head, and you could watch my thought process during the live portion of this. But then after this, I was like, oh, in this case, how many ways are there? Like another way to phrase it is, how many subarrays are there that starts at a given index, right? And this is actually ... so it doesn't end. This also is a ... so it doesn't end. But yeah, right? So then another way of saying is, how many subarray is there that starts with each index, right? And well, the number of subarray that starts at this index is just when both requirements are met. Meaning the min and the max, right? So that means that we go, okay, we basically see what's the first one and what's the first 5, and then make sure that both of them are in there, right? So that's basically the idea, is that, okay, for example, for this 3, the next 5 is here, the next 1 is here. That means that we need to include at least both of these, and then everything to the right is freedom, right, to choose. So then we count those. Same for 5, same for 2, and so forth. Because for this 2, you have this 1 and this 5. So that means that these are the required components along the 2, of course, and then everything to the right is free. That's basically the idea, and we'll look at the code now based on this visualization. And I would say that you can actually do this in a better space. I kind of wrote this in a weird way, but because basically the idea is that you can have, okay, let me go over my code first and I'll talk about optimization later. Basically, I put all the good index on a queue. That's basically what I have here. And then basically for each index, I count the number of index or number of subarrays that starts at the current one, right? So here what I want from the min k and the max k is we want the next number. We want the next number such that, like for example, this gives us the index of the next min number, and this gives us the next index of the max number. So this is the right boundary, if you will. So then now m minus nx is the number of degree of freedom that goes beyond that, and then we just summed up all together. So this is all going to be linear time, linear space, because, well, this is linear time because they just partition it, and here is just linear space and linear time because there are 4 loops, and each number gets added and removed from this queue once. So it's going to be linear time, linear space all together. So you can actually reduce this to constant space by noticing that you can actually, this could be a pointer, right, to the next number, and if you go past it, then you move the pointer until you get to the next number and so forth. So if you do that in an amortized kind of way, that's going to be O of 1 space, and that's pretty much the idea. Yeah, that's pretty much all I have for this one. Let me know what you think. I hope that my dot process made sense. Yeah, that's how I kind of solved it. It took a little bit longer than I would like, to be honest, but I'm going to blame it on the jet lag and stuff like this. And it's 4 a.m. in New York right now. I'm really tired, but hope you have fun. Anyway, you can watch me solve it live next. You can watch it a little bit faster, but I think at the end, or near the end, when all the light bulbs kind of came together, I think that may be interesting, so definitely check that out. But yeah, that's what I have, so I'll see you in a bit now. Okay, that was silly. I gotta slow down. I think that's the answer. I keep on not slowing down, even though I keep on saying I should. Okay, nums and 2 integer. Okay, actually read the form. Minimum return fixed bound subarrays. What does that mean? 135, 1352. Say what? Say what? Say what? Do. I don't get it. I mean, this is just whatchamacallit, right? What I don't get it is I don't know if this is just too easy or is it just me. Why is this? Oh, it's equal to exactly thing. Okay. Maybe it's not that easy actually, but it is very annoying. How do I express this? OMQ, no, don't want to do it. I'm trying to think about a clean way to do it. I mean, I know that you can do it like mono stack or something, but I'll just if we do it lazily, it would be n square. So let's not do that. So basically, for every contiguous thing, right? There's so many ways of doing it that I'm not confident about it. Should be able to do it in linear time. Yeah, okay, fine. Okay, these are the index that we care about. Right? And then we want to make sure that Maybe I try too hard to make it linear. Maybe I could just do. Maybe I'll just do binary search and not be dumb about it. If I do it that way, it should look at every element pretty okay. This is such an annoying one to write. Like, I don't think it's hard conceptually, but still. You want to. I also have to be really careful about. So we want. There are too much edge cases. I don't want to do it this weird way, but fine. Okay, first of all, we have to see what are the numbers in between. I think we can do that naively. If this is the end, then we just get out. I'm trying to make sure that I don't do the case where for every x I keep on matching the same number. This is so annoying. I'm just being annoying about it. Because then it becomes n squared if I'm not careful. That's not true either, right? Because if it interrupts earlier, man, I am like really failing on this one. just trying to think through all the edge cases, that's all. Let's see. Actually, I guess I can do it another way. How do I want to do it? I think I know what I want to do, but it's still very annoying. Okay, I know what I want to do. Wow, that is once they match, then we don't have to do any more work. Yep. Okay, maybe that's true. We'll do it this other way as well. Okay. And what I want now is just add min and max. Min element. I guess it's just actually, I don't even need to do this. I think now that we have each component, we can look at each component. And then, okay. Right. Let's see. I'm close. Focus. We want to put it in a thingy, right? Yeah, okay. I don't even need that, maybe. Well, I need a boolean. Okay, fine. You could do it a few ways. Yeah, let's do it this way. Why not? Spend too long thinking about it. Okay. Oops, I think this is lazy on the copy and paste. 1010. That doesn't seem right. Oh, I see. Oh, I messed up. Because it's not only the length. So then here it goes all the way left and all the way right, but oh no. Might have made a mistake. Okay, let's see. Right. Why didn't I just do the mono thing? Oh no. Oh no. Why am I? How do I fix this? Because basically the idea is that this is forced. So anything. So it's not just the length. Wow, I don't know what to solve this. I actually made a mistake here. My other way would have been okay, but okay. So now we have the longest one that contains min and the max. Now we have to take out the minimal pieces and then subtract that out. But each component could have multiple of those, so that's the issue. I messed up here. Huh. I feel like I did this column before and not in this funky way. Yikes! Oh no, how much time do I have left? Actually no, before we finish I imagine. Wow, this is pretty yikes. Wow, built in like 3 minutes. Okay, well, this is not a great situation for me, and I don't know if I could change my current code to fix it. I think I missed a point here. There are a couple of ways, so many ways to do it, and I did the wrong way. Dive, focus on. So many edge cases I'm trying to think through. I messed up. How do I refresh? How do I restart? We can redo this problem by taking out the numbers that are in between outside, and now we have just this, and then we can we figure it out from that? I think the thing is, if I have multiple mins and multiple max, how do I figure out the minimal amount, right? Like, maybe I should have thought it for a little bit. Like if I have a case where something like this, what are my possibilities? I really messed up on this one. I think I didn't think it through. Like, this is a minimal one. This is a minimal one. How do I know that this is not a minimal one? Right? So then you look at this and then you go, okay, all the other ones are fine. I think I'm missing a concept here. This is way not great. Seems like, wow, people are really fast, so. Okay, come on now. I feel like I've done. One of my problems, I don't know how to get rid of the overlaps or something like this. Something like that, maybe. Should have known. Okay, so then now we split it off. That was a much easier way than whatever I was doing. Okay, and then now for each one, how do I figure that out? How do I figure out this case? How many are there? Because this is minimal. Because, okay, so these two, man, I am really off today, am I? So basically, if I have this, what is the answer? How do I take apart the overlaps? That's the part that I'm just struggling with. We match 1 to 5. Okay, so for every number, can I do it the other way? For every number, do I remove it if it cannot exist without it? Like this 2. 2 is the only weird case where 2 cannot be. No, that's not true. Basically, could we do so there's how many cases are there, right? Let's actually just write it down instead, because I usually write it on paper. But so we have this, we have this, Yeah, okay, so there's 4, right? That's fine. But then you also have 5, 1. And of course, this last one is the overlap, which is the part that I don't know how to deal with, right? I feel like I'm missing one observation about this that lets me deal with this part. Oh, I can just delimit it by the 1, maybe? If I delimit it by the min, what happens? Well, let's say it should be by symmetry. What if I delimit by the max? Then I would have 1, 3, 2, 1. And then how do I match up the mins? It's still a little bit awkward, I think. I think it's just that happens that the ones are at the edge. Wow, today I am struggling with this one. Focus. So let's in this perspective of this 1 and the 3. Then we can know that there's 4, which makes sense. And then skip to the... Oh, if we just add track to the right, is that enough? Because now we're saying we're starting from that. Okay, I think that makes sense. I think that makes sense. Okay. Fine, Larry. You are slow, but if you could solve it, then even if it's slow, it's fine, maybe. So basically, kind of did what I kind of had before. Okay. Oops. Okay, I get it. I forgot about this technique. I don't know if it's a technique, but this observation from another contest I did before. That's similar, but this time, basically just don't go backwards. Just the answer. Wait, can it happen? Because then if we don't go backwards, then the 251 is not quite right. Well, so okay. So we might have to actually do go backwards, and the 351 thing is also. Okay, so let's say we for I, and then we look at the next 5 and the next one. Okay, I see. Maybe that's the way to do it. Yeah, okay. Maybe that's the way to do it. Okay, and then now for I again, then now we get the next. Okay, I see. If maybe, I don't know. We don't know if this is right, but okay, so man, I'm really bad though. I maybe should have done this earlier. I think I missed that one observation. So then the next min, so min x is smaller than I, then we pop left. Okay, and then now we want to get the next. So next is equal to max of min x0. If min well, we break, I guess, because just you need both. Okay, otherwise we take this, and then now the extra number is going to be equal to m minus nx, maybe plus 1, something like this. Is that it? Okay, I missed one observation, and that, or not observation. It's like a counting technique. I forgot about it until I have to. This is where drawing it out and visualizing it helps. I probably should have done it earlier, but I was kind of lying to myself, to be honest. Like I thought I could do it in my head, but I didn't. And once I drew it out, it actually became way easier. And I honestly spent way too long drawing it out. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this problem and the review and so forth. Hope y'all did well, and that's all I have. So stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.